So this week we're discussing hydrophilic versus hydrophobic. Hydrophilic is defined as having a tendency to mix with, dissolve in, or be wetted by water, with the opposite being hydrophobic, which is defined as tending to repel or mix with water. So both of these have uses in both life and lab. One of them being hydrophobic tends to be polar, both negative and positive. And therefore, it attracts other both positive or negative, depending on the polarity, ions to help bond with the water. A couple examples of that would be like aminos or alcohols, also things such as sugars, salt, starches, and cellulose. Hydrophilic is used in things such as hydrophilic membrane filtration, which is used to filter out things like bacteria. On the opposite, you have hydrophobic. Hydrophobic liquids are nonpolar. Examples of those would be like fats, oils, or grease. And you can see just the separation of water versus the oils that you put in them as a very clear demonstration of a hydrophobic material. Hydrophobic materials are used to do things like remove oil from water or manage oil spills. They're used in that cases to have a nonpolar attract another nonpolar to help pull the materials out of the water. So both hydrophilic and hydrophobic have both positives and negatives to them. Hydrophilic tends to dissolve in water, which makes it easier when you're doing experiments. It helps you give it a base. You can also change the pH of the liquid based on what you're adding to the water or the starting pH of the water. In hydrophobics, it helps you see if it's just not going to blend. It usually has different characteristics to it. The non-polarness to it helps you be able to separate layers or be able to hold substances at different levels so that you can further an experiment to see how different materials will dissolve in different substances, such as having a layer of oil on top of water. You can see buoyancy or the dissolvability of a different substance between the two layers. So hydrophilic versus hydrophobic are complete opposites. Either does dissolve in water or doesn't dissolve in water, but both of them are completely useful in their own ways.